Namaste to all my dear students. How are you? Today I am giving you very nice lecture about the what is the atomic hydrogen, allotropes of hydrogen and occlusion of hydrogen. It's very important for knowledge as well as what you see knowledge as well as what you see examination view of points. So first one is atomic hydrogen. Atomic hydrogen, what is the allotropes? Allotropes of hydrogen and occlusion of hydrogen. Yes, first one is atomic hydrogen. When hydrogen gas is passed over heated tungsten wire at 1000 to 2000 degrees centigrade at low, we get what is atomic hydrogen. Atomic hydrogen. It is strong reducing agent. It is highly reactive. It is highly exothermic. Exothermic means thermic because it liberates about 4000 degrees centigrade. It's very high temperature. So just like this, that is the hydrogen gas, reversible sign, tungsten wire. So at 1000 to 2000 degrees centigrade, low pressure. So what you get? That is atomic hydrogen. Yes, that is molecular. Yes. So what you see? So when hydrogen gas is passed over tungsten wire is what you see. So tungsten wire resistance is very high. Melting point is also very high. Boiling point is also very high. So we have to heat up to 1000 to 2000 degrees centigrade and low pressure. So what you get? Atomic hydrogen. That hydrogen very reactive, very exothermic, and what you see, it liberates temperature about, this is the sign of about 4000 degrees centigrade. Yes. So what we see over here, that is about the atomic hydrogen. So atomic hydrogen, sometime ask you, how can you show atomic hydrogen is more powerful reducing agent? Reducing agent, yes, sometimes ask you. So what is when atomic hydrogen is reacted with heated cupric oxide. What you see, silver oxide and ferric chloride separately we get metallic copper, silver and iron respectively by reduction. But what you see, by reduction process, like produces like. So when suppose cupric oxide must be heated, so when what's the atomic hydrogen, so what is the process is reduction. Process is reduction. So what we have, copper metal plus water. So yes, so oxidation number is 2, in this case oxidation number is 0. So what you see, reduction from +2 to 0. So what you see, how many hydrogen? 2 hydrogen. How many oxygen? So that is balance. Next one is silver oxide. Silver oxide, when written with atomic hydrogen, process is same. So what you get? Ag, metallic silver plus what you see? H2O. So how many Ag? 2. So what we have? 2 Ag. Hydrogen is what you see? 2. And oxygen is 1. So what you said? 2 hydrogen. Yes, process is reduction. So +1 to what you see? 0 oxidation number. Likewise, when you talk about ferric chloride, so what we have, that's the process is same, reduction, and what we have, iron metal plus how many chlorine? 3 chlorine, 1 iron, so that is what you see, 3H. Yes, balance. So what you see, +3, in this case what you see, 0. See all cases what you see, reduction of oxidation number from first case +2 to 0, +1 to 0, in this case +3 to 0. So how you can show with the help of these reaction, the atomic hydrogen is more powerful reducing agent. Yes. Next one, sometimes ask you, question is difference in between what is the atomic and nascent hydrogen. Yes. So first difference is like this. We have already observed atomic hydrogen is generated when hydrogen gas is passed over heated tungsten were at 2000 degrees centigrade and low pressure. You have already seen, but nascent hydrogen is prepared at room temperature between the reaction of granulated zinc and dilute sulfuric acid. We have already studied about the nascent hydrogen, atomic hydrogen. First difference. Now the second difference is like this. Atomic hydrogen is more powerful reducing agent than nascent hydrogen. So you can say that is more powerful than nascent hydrogen. Now third one is atomic hydrogen can be isolated, can extract it, isolated in lab, but nascent hydrogen cannot be isolated. Yes, so these are the main differences between what we see atomic and nascent. The first one is at high temperature atomic hydrogen, but nascent hydrogen normal temperature. Yes, zinc dilute sulfuric acid in better. Second one is atomic hydrogen more powerful reducing agent than nascent. Third one is atomic hydrogen can be isolated in the lab, but nascent hydrogen can't be isolated. So, yes, these are the main differences between atomic and nascent hydrogen. So, I think you have cleared. So, generally very, very important for examination viewpoint. Next one is what is the allotropes of hydrogens. So there are two, ortho and para. Yes. So at first we have to know what is allotropy. Allotropy. So different, simple language, different forms of same element which has similar chemical properties but different physical properties like melting point, boiling point, density, etc. Our reason is due to different structures, so they are due to different structures, so they are known as allotropes, and properties itself is known as allotrope. So we give very simple example. So what we say, diamond. For example, take very simple example, diamond. Diamond, it is the different forms of carbon when burnt in air at 800 to 900 degrees centigrade. So what you get? That is the sign of heat. So what you get? CO2. Likewise, you know graphite. That is also the allotrope. So what you see? O2. When heated at 700 degrees centigrade, what you get? CO2. Yes. Yes. So never, if you know the example, you have never problem. So when talk about the diamond, it is the form of carbon. Yes. So when burned in air, what you get? 800 to 900, what you get? CO2. Likewise, graphite, that is also the form of different form of what you see carbon. When heated at 700, what you get? CO2. So what you see according to definition? Different forms of same element which have similar chemical properties in both cases. What you get? Carbon dioxide, carbon dioxide. But when you talk about the physical properties, in this case what we have? 800 to 900 we have to heat, but in this case we have to heat only 700. So what you see? Chemical properties are same but physical are different. Why? Due to different structures. So diamond and graphite are the allotropes of carbon. Yes, allotropes of carbon. Yes, but these properties by which they are allotropes to each other, so that property itself is known as allotropes. I think we have clear what is allotrope. Now we are talking about the, what you see, allotrope of what you see, hydrogen. Allotropes of hydrogen, two types, ortho and what you see, para. Yes. So first one is what you see, ortho. Ortho hydrogen. If the nuclear spin of two atoms, hydrogen molecule are in same direction, are known as ortho, known as what you see, ortho hydrogen. But when talk about the para, so what we have? Para hydrogen. If the nuclear spin of two atoms of hydrogen are in opposite direction are known as what you see? Para hydrogen. So see the pair? Two atoms of hydrogen, that is the nucleus, one electron over here, one electron, nuclear spin of what is it? Nuclear spin, that is the nucleus, that is what you see? Ortho. Hydrogen. Next one is clockwise direction, that is anti-clockwise direction. So that is para hydrogen. So what do you see over here? So tell me, according to your ideas, according to you, which one is more stable and why? So in this case, nuclear spin is what you see, that is the nuclear spin in what is the same direction. So there is no possibility of what is collision of the atoms of hydrogen. But this in this case, one is clockwise, another one is anti-clockwise direction, nuclear spin. So what is the possibility of collision to each other, and what you see, it is more unstable. So that is more stable. So at normal condition, what you get? At normal condition, we get about 75% or out of 100 part of hydrogen, we can say, that is less stable. So in this case, what is normal condition? What we get? About 25%. How much? 25% only. Why? Because it's less stable, that is more stable. Yes. Always also see when we increase the temperature or decrease the temperature, what effects you get over here. So what you see, if always keep in mind, if we increase the temperature, most of the, you can say, most of the para is converted into what you see, orthohydrogens. Always keep in mind. Likewise, if decrease the temperature, most of the orthohydrogen is converted into parahydrogen. So experimentally what we see at minus 253 degrees centigrade. So what do you get? 99.8%. So what do you see? If temperature is decreased at minus 253, so at that temperature about 99.8% parahydrogen. Yes, we have clear what are the orthohydrogen, what are the parahydrogen, what the relationship of temperature, what the structure of what's the ortho and parahydrogen. So I think we have clear. So sometimes ask you write down the allotropes of hydrogen. Sometimes ask you what do you mean by ortho and parahydrogen. Write down the effect of temperature on what's the ortho and para. So you can write. I think I've already given you all ideas. Yes. So that is about the allotropes of hydrogen. Next one is occlusion of hydrogen. Occlusion of hydrogen. Yes. So certain metals like gold, platinum, palladium, etc. Certain metals like gold, Pt platinum, Pd palladium metal. Certain metals like it when hydrogen gas is passed over these metals separately. So what you see, hydrogen gas is adsorb, not absorb only surface. Adsorb means only surface. This adsorb separately. Hydrogen gas is adsorbed surface. Gas is absorbed by these metals to give solid gas solution known as occlusion hydrogen. So two terms, absorb and adsorb. Adsorb means absorbing at the surface of the material. Absorbing means whole body. Yes, so what you see when hydrogen gas pose palladium, that is palladium metal, that is the selective metal. So what you see past, so what you get PD, yes, to PD is solid, S2 is gas solution. What type of solution it is? Solid gas solution. Process is known as occlusion of hydrogen, yes, and that metal is known as occluded metal. Always keep in mind when this metal is heated, yes, so occluded metal is heated, so what we have? Palladium plus S2, that is palladium, that is the pure gas. Why? Because palladium absorbs only the hydrogen gas. So in this case, what you get? Pure hydrogen gas. Yes, we have clear. What is the occlusion means? When this hydrogen gas is passed over the PD metal or AU, yeah, platinum. So what is it? There is a process of occlusion, and what you get? Solid gas solution. PD is solid, hydrogen is gas. This process is known as occlusion of hydrogen, and that metal is known as occluded metal. But when this metal is heated, so what you get? Palladium plus hydrogen. That hydrogen is pure hydrogen. So always keep this. So we can prepare pure hydrogen by this method. Yes. So that is the very important. So another one is activity. Reactivity of hydrogen. So sometimes ask you in competition exam, so write down the reactivity of hydrogen gas. So what do you see? Atomic hydrogen, nascent hydrogen, occluded, and last what do you see? Molecular hydrogen is what see least, that is the maximum. So atomic hydrogen has maximum activity, then nascent hydrogen, more than what you say occluded hydrogen is more than molecular hydrogen. Least, that molecular hydrogen has least what you see reactivity. So always keep in mind. So thank you for watching this what you say important video, and I think we have already done subscribe and also convey your friends to what you say convey your friends for learning, I think. So I think have a nice day. What you say, be happy, be healthy, always be a smile. Yes.